Hey guys, welcome to Learn Electronics. Today we model a DC motor. In this motor model, we provide the input signal to constant input signal to our motor, and we check the current and the rotational motions of our motor. So in this motor model, we use a several blocks, like we use a solver configuration. I show you the block diagram of every uh, component or part in the Matlab and Simulink. Before we start our modeling, I just defined the blocks and what are the uses of these blocks. We use a solver configuration. We have the PS converter. PS converter is nothing but convert the physical signal to the Simulink control PWM voltage. Control PWM voltage is nothing but we like if you provide a DC voltage source to your model. The control you know takes the constant input signal to the your DC voltage source, and they produce a PWM signals to the your for your motor drive. We have the edge which is a drives the DC motor. We have the DC motor that convert the electrical energy into mechanical energy or mechanical, and we have the DC voltage source like I already explained it, electrical reference, or it is just for ground purpose. And we have the mechanical rotation reference for mechanical ground purpose. We have the ideal voltage motion sensor. Ideal voltage sensor it converts your rotational motion into the physical signal to the motion. And we have the scope. Before we starting for the modeling in Matlab and Simulink, let I just show you the block diagram of our model. So we have the constant input signal or constant DC voltage source. We connect with the control PWM voltage. We have the edge bridge always connect to the current sensor. We have the DC motor. We have the current, we have the ideal rotation. You check there is a color difference between the different types of signals. Like there is a blue color for the electrical signal. They have the and they have the green color for the mechanical. They use a different color for the different signals. We use the physical signal. They have the different color. So this is a differentiate the with the use of colors. The MATLAB will differentiate the different types of uh, systems like electrical system or mechanical system. With the use of PS converter, we convert the current sensor because current sensor produce a physical signal, but we want a Simulink signal, so we use a yes Simulink differentiate the with the use of colors. The MATLAB will differentiate the different types of uh, systems like electrical system or mechanical system. With the use of PS converter, we convert the current sensor because current sensor produce a physical signal, but we want a Simulink signal, so we use a yes Simulink converter. Now we model our DC motor in Matlab and Simulink. So first we have to click on the Simulink, so we can and tap on the blank model. After the blank model, create the untitled Simulink page. You can click on the library browser and open your library. Now we have this library. So for this project, we use the different types of blocks. One by one, we take it from our model. First, we use in Simulink commonly used blocks. We take the scope to our model. Now, now go to the Simulink. Now go to the Simscape. Simscape in Foundation Library. You have the electrical elements. You have mechanical. You have the hydraulic. You can use any block system. For our purpose, we first take the electrical elements. One by one, we take the every element. Like we need the electrical reference for our system. We also use the electrical sensor. Like electrical sensor, we use here the current sensor. We take the current sensor, DC voltage, DC voltage source. Now it's time mechanical. Now mechanical. Mechanical sensor, we need ideal rotational motion sensor. Take it. We also want a rotational element for mechanical rotation reference. We also want some other elements like we want electromechanical brush motor. We use a DC brush motor or DC also brush motors. Now we take some converters. So whether we use edge bridge for integrated circuit, we can take WM voltage. Now we want to connect one, so we don't need the library. If we need, we just add the components one by one. Now I am arranging all the blocks. Now I am connecting the signals. First, DC voltage source to our control PWM input, and negative part of this or minus or negative the DC voltage source to connect to ground. You can arrange the block easily by just click using your mouse. This RPU but now this is the primary. Nice to give the parameters the different blocks. Like our now first I explain all the parameters in this model. First one is constant voltage source. We given the constant voltage source is 2.5 volt and the control PWM voltage block parameters like PWM frequency is 4000, Simulink mode is to average, and therefore test one by one. We give all the parameters to be our just like for example, we give the 2.5 volt to our DC input voltage source. And just apply and okay. It's time to give the parameters to the control PWM frequency. Just click and we given the PWM frequency is 4000 Hz and our simulation goes to H. Just one by one. Simulation mode is to H. Just write comment. And the second one is RP. Just write this RPU simulation per. Now this is the primary. Nice to give the now now it's time to give the parameters the different blocks. Like our now first I explain all the parameters in this model. First one is constant voltage source. We given to constant voltage source is 2.5 volt DC motor. The armature inductance is 0.01. Inductance is 0.01. No load speed. No, it's 4,000. No load speed to 4,000 RPM. 4,000. Rated speed. Rated speed is what is the maximum speed which can be achieved by the motor at rated load. And load speed without any load. The parameters rated load, which is rated load is 10 watt and is flash. I just write the parameters to show you what are the parameters, what are the different parameters we use in our model. Now it's time to give the mechanical rotation is rotation inertia is 2000. Rotation is defined 1 e to the power minus 6. Let's check so again. Now time to save our project. So go to the save